Hello again, ladies and gentlemen. This is Dr. Robinson, and we're going to continue our studies. We are going to be solving for a variable in a formula, which is another way of talking about literal equations. Here's a formula. A formula is an equation that contains more than one variable. And we know a variable is a letter. So here's a formula, the distance formula, d equals r times t. R stands for rate, t stands for time. Some of the teachers in science use the formula this way, where they're looking for the rate of speed. R is equal to d divided by t, distance divided by time, as well as looking for the time, where the distance divided by rate. So notice how the formula is manipulated. How do they do their manipulation? Well, here's a note that you should see. An equation may contain more than one variable. To plan the steps in the solution, it is helpful to use the strategy of using a simpler related problem. That is, compare the solution of this equation with the solution of a simpler equation that has only one variable. So we have two questions here, ax plus b equal 3b, and we made one that's more recognizable if we were solving for x, 2x plus 5 equal 15. So we're used to solving these two-step equations, but this is a linear equation that is linear, but it has a lot of variables, which makes it literal. So let's take a look for solving for x. So here's our equation that we made up. So we chose some compatible numbers that we could replace a and b with, and here we go. So we have 2x plus 5 equal 15. So what I'm going to do is do the additive inverse, because it says plus 5. I'm going to minus 5 from both sides. And in turn, on this side of the equation, I have plus b. I'm going to minus b from both sides. So that way, what happens is the b's end up canceling out. So let's cancel out the 5's here, but over here, the b's end up canceling out. Because I'm trying to get the x by itself, so I'm ending up with the x on the left side, like here, bringing down the 2x, and the 5's canceled out, leaving me with 15 minus 5, which gave us 10, which we would normally do if we had a regular number. But here we have ax, and we have 3b minus b. Well, that we can combine because those are like terms there. So you have 3b minus a b, that 1b gives you 2b. So look for similar terms. Sometimes in formulas you'd have to just rewrite it, but you can combine like terms. So check out my video on adding polynomials. Alright, so we have 2x equal 10, so we would divide both sides by 2 and solve for x. So here we have 10 divided by 2, would give us 5. Well, the same thing here, we would divide by a, and notice when you divide 2b by a, you don't have a number here, because ax is equal to 2b, so we're trying to get x by itself, so we would divide by the coefficient, the the a, so that would cancel out, really cancel down to 1, and 1 times x is x, and 1 on the bottom, that would be x over 1, which would just be x. And here we don't have anything that we can cancel out, so we just have 2b, 2 times b over a, and that would be our answer. And it's in the formula situation there. So that's our answer. So let's look at some problems and see if we can do them. So here's our first question. Solve for x. We have x minus a equal b. So we want to get x by itself. And as we said in our steps, look for some compatible numbers that you could use. So I'm going to write x, say minus 5 equals, and a is a different number from b, so I'm going to put a different number here, 3. So I have two different numbers, and I'm going to do what I normally do in a one-step equation. Here I'm just going to add the additive. I'm going to add the additive inverse. So I use the additive inverse to cancel out the 5s to both sides. My 5s would end up canceling out, and I'm going to look at my negative sign here, my minus sign here, use the additive inverse, which is plus a. So plus a. And I have the a's are going to cancel out on this side, leaving me with just the x. And on this side as well, leaving me with the x. And the a's canceled out as well as the 5s canceled out, leaving me with 3 plus 5, which might add up to get 8. And that would be my number over here. But over here, we're interested in the process because we cannot add b and a together because they're two different types of monomials. So all we can do is just rewrite this and leave it as it is. So it'd be x is equal to b plus a. So let's see what we got. There it is. X equals b plus a. So that was our first question. So here's one for you to try. Solve this one for x. See if you get it right. Be careful. You don't have, like we did, having the two different variables. You have the same variable. So look out and be careful. Check your understanding. If you understand it so far, it's great. We're happy about that. But if you're not sure, rewatch the video and write down your questions, bring them in, and I'll be glad to answer them in class. Here's another question. We're going to move up a little bit, solving for k. This time we have 3k minus 8r equals r. So let's, excuse me, let's look at this. And it's like a question we've done before, but I'm just going to look at this and deal with it like I did before by using the additive inverse. I can make an easier question, but I'm going to look at this because I notice I have the same variables like I did in the last one just a minute ago. And my 8 r's would cancel out, leaving me with the 3k. And I have one little r, and they don't write the 1 in algebra for some reason. So we can write it, and we have one little r plus 8 r's. That'll give us a total of 9 r's. So now we could solve this for k if it were like, say, 3k equal to 9. So we would divide by 3, but let's get over here on this side, divide this by 3, divide this by 3, and cancel out the 3's. And k on this side would equal to, well, we have a 9 divided by 3 will give us a 3r. So our answer would be k is equal to 3r. So we were able to combine like terms because this was a r up here and that was a r down there. So we were able to combine them to give us a total of 9 r's. So if you forgot how to combine like terms, check out my other video on adding polynomials. So our answer is k is equal to 3r. So here's another one for you. Try it. See if you can get it, solve it for g. So be careful. It's similar to that one. So watch your numbers. I hope you're understanding what's going on so far. If you're not, rewatch the video and write down your questions, and I'll be glad to answer them. Here's another one. M is equal to 2 parenthesis y plus n. Now, this time I'm going to do like the steps say, make up some problem that's similar, and I'm going to use some compatible numbers. So I'm going to make believe that this is 14 for m equals, say, 2. I don't know what happened there. What happened? Where we go? I'm sorry. Disappeared on me. So I got 2 times y plus, I'll make believe this is 3. Alright, so I have to solve for y. So normally I would distribute, and that's what I teach my accelerated students to do, to distribute the 2 to the stuff inside the parenthesis and then solve it. But I'm going to show you a little secret that we do in accelerated math. We look at these situations to see if we can solve it a lot faster by doing the opposite of what they're saying. So they're saying multiply by 2, but I'm going to do the opposite, which is divide by 2, both sides. Why? Is because what it does is it cancels down the 2 to 1 times that stuff in the parenthesis. And 1 times that stuff will be just leaving that stuff inside the parenthesis. And I can even eliminate the parenthesis and write that. So if I divided that side by 2, I'm going to do the same thing over here and divide this by 2 so my 2's can cancel out over here. So I'll have 2 divided by 2, which cancels down to 1, and I'll have y plus n down here because my 2's have canceled out. And so on this side, I'm going to have m over 2. And over here, I would have equal to 14 divided by 2. And 14 divided by 2, we know it's 7. But I'm not going to do that. I'm just going to leave the steps and process because that's what literal equations are about, just the process. Now, I want to get y by itself, so I have a plus 3 here that I got to get rid of. So I'm going to have to use the additive inverse, which is minus 3 to both sides. So do a little transpositioning there. So I'll minus 3. That way, my 3's are going to cancel out, and it'll leave me with the y that I need so badly. So I need y by itself. But if I minus 3, over here, I'm going to do the same thing with the letter n. I'm going to minus n from this side and minus it from this part here, this m divided by 2. So that way I'm showing the process of what I'm doing. And as I said, the n's would cancel just like the 3's canceled out, and I'd have y all by itself, and now I'd have m over 2 minus the letter n. So remember, this was going to be divided by 2, giving you some number, then you're going to subtract 3 from that, and that'll give you y. So like here, 14 divided by 2 would have given you 7, and then you would subtract 3, and you would get 4. So if you did that question throughout, you would get your answer, but they're not interested in the answer, they're interested in this process. So that's what literal equations are about, showing a process. So our answer is going to be, let's press the box, m over 2 minus n, or you could say 1/2 of m minus n. So that's a nice question. I hope you enjoyed it. Here's one for you, solve for a, similar. So try it. I hope you get it right. Check your understanding. If you're understanding so far, great. If you're not, check out the video again and write down questions and bring them in. Oh, it's challenge Dr. Rob problem time. So Dr. Rob's challenged me problem time. So here's a problem for you to try. Solve it for X. So I hope you get it right. Bring in the answer in tomorrow and we'll talk about it. Here's another one. Oh, this one's really good. Solve for X. So try that one. Got another one. This one is a really good one. This one came from one of the regents in the 9th grade. So if you can do this one, you're in good shape. And here's one of my favorite ones, solve for R. This here is a volume formula. So if you can solve for R, I know you're really good. So I hope you found the lesson easy and helpful. So write down any questions. If I can be of assistance to you in class, please let me know. I'll see you in the morning. Bye bye.